Okay, well, thanks for coming and welcome. This is a course entitled Introduction to Python Programming. And I'm Jeffrey Ubona. I teach down in Texas. I'm an associate professor at the Texas A&M International University, way down in Laredo, Texas. Interesting place to be. So I started teaching Python just a little over a year ago. I teach it at the undergraduate level, and much of this material is derived from that course with some modification. I use a book. I use different sources, but a lot of this material comes from a textbook by Murach, M-U-R-A-C-H, called Python Programming, second edition. And I do use that in my class, but also I use it because it's really very good. And I like the way it presents the material. It's got a lot of examples. It starts from the very beginning. Again, this course is really for beginners. Now, if you do have some programming experience, and I'm assuming that many people here do, that's good. I mean, that certainly will help you and make it easier for you. I hope it's not too easy, of course. So here, let me get this material. And okay, the first thing I wanted to do really is to show you your materials and what you had. I emailed everybody a zip file, and it looks something like this. Okay, and we'll do this every week, 6 weeks. Here's the day one material. I'm not a big fan of slides, especially in a programming course, but some slides help for sure and are useful for instruction. So there's some slides, but we'll be skipping from back and forth from the slides to the software itself. I have scripts. Many of the slides, especially when we get into the second, third day, most of the slides really are of code, of Python code. And so to demonstrate how they work, I've made scripts. These are all Python script .py files from those slides. So we have 5 or 6 of them today that are little snippets. I call them little snippets of Python code to demonstrate what's going on in the slide. But you'll find that as we get into day 2 and 3, there'll be dozens of these things. Okay, there are also programs. Well, here's the Python download instructions. Hopefully all of you have done that and downloaded the current version, which I believe is 3.11.4, along with IDLE. I forget what IDLE stands for. It's an IDE for Python. And we also have a number of programs. I'm not sure that we'll examine each of these in detail, but we certainly will take a look at them. They demonstrate a lot of the concepts, of course, that we're going to be talking about. And then finally, exercises. And this first one, I called it an assignment. It's not really an assignment, but it's an exercise for something for you to do between now and next week. And at the beginning of session 2, next week, we'll look at it. We'll look at my solution, my version. This first one really just looks at input and output, which is really basic stuff. You know, how the user can interactively respond to prompts to instantiate values to variables that are inside the program, and then to present that material back to the user. So you need to use functions, Python functions such as input and print. And we'll talk about that later when we get near the end of the session. We will generally go for an hour and 10 minutes, and then maybe take a short break, 10-minute break, and then come back and finish up. Okay, so you can expect to get something like this from me every week, and generally a day or two before the class begins. Okay, so let's go over here to the slides. We'll put this over in the middle. Okay. I'm facing a sunlit window, so it shows me as being quite bright. That's fine. Okay, so let's talk a little bit about what Python is. Now, here I'll expand this to full. I can't figure out how to do that. Add notes, don't want to add notes. There should be a little. It's over here. Here it is. All right. Okay, so Python, as you probably are aware, is a very popular programming language. It's a so-called higher level language. It's very English-like, which is probably one of the reasons why it's so popular. You may or may not know that computers think in terms of machine language. In fact, at the most basic level, computers think in terms of bits, ones and strings of bits, ones and zeros. So Python is very English-like, and which makes it very easy, of course, for the user to see and understand. But the flip side of that is it's difficult for the machine to figure out what you're trying to get it to do. And we'll talk more about this, but one of the fallouts of the fact that it is a so-called higher level language, it's very easy for people to understand, is that it takes a long time to interpret and to compile. So it's slow. It's a very slow language. And Google has hired some brilliant people to try and fix this problem. One of them was the original developer, Guido van Rossum of the Netherlands, the guy who thought up Python to begin with back in the 90s, to try and make it faster. Now, a lot of companies build entire platforms out of Python. I believe YouTube is built on Python. So it can't be that slow, but the speed does become an issue when you have enormous data files and you have very large applications. For what we're doing in this class, of course, you won't even notice it because the files and the scripts that we use are so small. Okay, Guido named the language Python because he was a fan of Monty Python's Flying Circus. And he continues to be a developer of Python, though he stepped down from a more active role just a few years ago. So just a few things about Python. Now, often people will ask me, well, is Python an interpreted language or is Python a compiled language? And that's a very good question. And frankly, it doesn't have a concrete answer. Normally, when you look it up on the web, you'll find this: Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. But interpreted really means that at some point, when you're trying to get the computer to figure out what your program is instructing it to do, it reads the program line by line. R is like this too. R is strictly an interpreted language. It will read each line, establish a value for that line, and then move on. Okay, so that's what an interpreted language does, like Lisp. Lisp is also interpreted. It will execute line by line. But Python takes that one step further. It interprets it, and then it compiles it literally into bytecode. Here, we'll look at this in another slide in just a sec. But so it's both interpreted and compiled. It depends on who you ask. It's object oriented, and we're not going to get into how you build classes in this course. I intend to create a second course also from Murak's book that looks at that a lot more carefully. Object orientation, of course, you have inheritance and you have encapsulation. and you have ease of maintenance. It has a lot of characteristics that make it faster running and easier to use. High level, again, high level just means it's very English-like. Dynamic semantics, typing and binding, that's a little more complicated. What it really means is that in many languages like C and C++, you have to actually declare the type of variable. When you create a variable, you have to tell the language whether it's an integer, whether it's a floating point, whether it's a string, whether it's a logical variable. You don't have to do that in Python. What you do when you create a variable and you give it some value, it simply assigns a location in memory that is the variable name, and it doesn't try and figure out what the type is for that variable until runtime, until it's actually executing the program. So it makes it a little easier to code because you don't have to go through all this minutia about, this is an int and this is a float and so on and so forth. And those so-called static binding, they're very hard to change. Okay, so we'll talk more about that later. Okay, Python, simple, easy to learn syntax. We've mentioned that already. Python has both modules and packages are generally called libraries. I'm an old R guy. I started programming in R 12 years ago and did quite a bit of it for 5, 6, 7 years. R, if you're familiar with R is both an object-oriented and a functional language, but the reason for the explosive growth in R was that everybody could contribute packages. And what a package is, or a library, it extends the capabilities of the base installed package. You can add functions and you can add data sets, and you can build and extend all of the capabilities, things that the computer programming language can do. And in R's case, anyone could do that. Now, if you submitted a package, a library, to be added to the next release of R, it would be thoroughly vetted. It would be, tested, and you had to meet these strict requirements in terms of documentation, in terms of testing, in terms of data. So, you just couldn't whip up a package and send it overnight and have it included. But many people with very deep domains of knowledge, very pointy head, narrow stuff, would submit their own packages to R. And so the power of the scope increased exponentially and became very popular. Now with Python, I'm really not sure if individual users can submit their own libraries or not. I haven't gotten into that. But there is an extensive library collection, which libraries, packages, same thing, that extend the capabilities. In this course, we'll be looking at modules. You could think of a module as kind of a mini package. Modules, again, are extensions for the base Python that, for example, there's a module that formats currency, and you can tell it whether you're in this country or in Europe or, Norway, and whenever you print a currency variable, it will print it out in terms of the appropriate symbols, a dollar sign, a pound sign, so forth. And we'll use some of those in this course. Okay, so